Okay, so usually what you do is you're going to write these methods. You're going to override. These are three predefined methods, virtual methods that objects, J components, have in Java. If you remember, J components are the so-called widget objects that you're going to probably draw into. So you can override these methods and provide your own sizes. These methods are typically used, these set methods are typically used with predefined widgets like buttons and text boxes because they have their own predefined methods that compute their natural size, their minimum size, and maximum size, but sometimes you want to override those constraints and provide your own preferences. So that's issue one. That helps the layout manager. If it is given your preferred size, your minimum size, and maximum size, then it can figure out whether the first option, which is expanding you to fit the available space, is an option. If you make your maximum size less than the amount of allocated space, perhaps it's not an option. So you're also, J components have a property called alignment X and alignment Y that allow you to specify its anchor points, where it gets anchored. On the left side, the right side, that's alignment X, alignment Y, top, bottom, center. So you're allowed to specify alignment properties. There are values between 0 and 1 that say where it gets anchored. And then another issue is what happens when you resize the container. So often you resize a window, and the layout manager has to figure out how to update the layouts, and then it's back to what happens if there's too much space, how it accommodates that. So we're back to issues 1 and 2. I'm not going to really talk about insets. And then there's finally this internationalization feature that's called component orientation. So in some cultures, things are done right to left rather than left to right. And it's rare, but in some cultures you have bottom to top orientations rather than top to bottom. So Java is an internationalized language. It gives you an ability to say either specifically I'm laying it out left to right or right to left, or to say use whatever setting is in the computer, and that setting will depend on the region where the laptop boots up, maybe based on GPS coordinates or something. And then it will automatically choose the orientation for you. Again, we're not going to worry too much about that. So, what the layout managers do, there's kind of two general strategies. The general strategy is a two-pass strategy. So you have a bunch of objects that you're laying out. So what you typically have is a tree-like structure. Whoops, not that. It's nice. I'll wake you up. Okay. Let's use that. So you may have this is your container, and it has a bunch of objects, some of which may themselves be containers. Some of them are just leaves, so I'll represent the leaf objects, but some of them may have further stuff. So it's a two-pass strategy. The first pass asks each is bottom up, and it's asking each component for its preferred size. And then you aggregate it in some way. So you ask each component for its preferred size. So that's bottom up. And then pass 2 is top down, where you tell each component what its size is and where it's located. So position each, the top down one, position each component. So assign it XY coordinates. So position each component, which means assign XY coordinates or XY values, and assign a size. So now each component has to make do with the size that it's been given, which may mean it expands or contracts to that size, or maybe it uses an anchor point if that size is too big for it. So that's the general strategy that pretty much all layout managers use, whether Java or if you're writing your own layout manager. If you're not in Java, you're in Python or C and you have to write a layout management algorithm. This is essentially the strategy. First, go down, walk down your tree of objects, ask for their preferred sizes. That information percolates up. Then you take that information into account. You try to position each component and assign it a size. Okay, so debugging. Just a quick thing about debugging. So there's two ways to do it. First of all, oftentimes the layout managers, especially when you're new, will put things in locations you don't expect. And you're wondering why the heck it's not working the way you want. I suggest you just put garish borders around the objects because that often tells you what's going on. So you may see the object laid out like this. Say button 1, whoops. You might see button 1, whoops, button 2, button 3, and this is the window. And you're wondering why the heck it ended up in the middle here, but there's some space here. You thought right here there's space. You thought that it would be hard up against the top, and it's not. So putting borders around things often show you what's going on. So you might find out by putting a border around it that this is the border. Or actually, you may, even better yet, find out that unexpectedly, this is the border. So for some reason, the objects aren't appearing at the very top. So by putting garish borders around objects, you can figure out often why things aren't working the way you expect. Now in this case, I didn't put the borders around the buttons. I put it around the container object that holds the buttons. So often you're putting the borders around both the objects themselves and the container objects. And there is every object has a set border method, and you can look up borders. You can just say Java Border API or tutorial, and it will quickly tell you how to set a border. So debugging in graphical interfaces with layout managers usually means to use a garish border. Okay, so now let's talk about a few mechanics in Java. And these are the important functions. Okay, it's worth writing them down because you will be using them. So J-frames, which are the windows, have a pack method. And they invoke the layout manager. So typically you call pack only at the very end, right before you are about to display the window, do you call pack. And that invokes the layout manager, and typically the layout manager will exactly accommodate each object's preferred size. So the container object typically will be just large enough to contain all of its objects. So that's pack. Another important thing is the getContentPane method of a J-frame. That will return a pointer to the container object for that J-frame, which will be, if you remember from last time, a JPanel. Then the JPanels have two important methods. One is setLayout, and that sets the layout manager. So remember I said layout manager, there's a class called LayoutManager, and then there are subclasses of layout manager for each of the main Java layout managers. So you create an instance of a layout manager and you call setLayout to set your container's layout to the appropriate layout manager. And then the way you add objects to a container is with the add method. So the add method will add components to a container. And typically the order you add components to a container is very important because most of the layout managers use that order to determine how they lay out the objects. You'll see why in a moment. So those are 4 very important methods that you'll be using a lot in your homework assignment. Okay, so Java has a bunch of layout managers. There's 5 major programmatic ones that are used: the border layout, flow layout, box layout, grid bag layout. Okay, and easiest is probably to just show you the visual catalog. So I will do that. Java Layout Manager. Okay, so border layout is good for the top level of an application. It basically lets you put a canvas in the middle, and then it gives you 4 regions around the sides to put your tool palettes. So you can see there's a top and bottom region, a left and right, and you can see the north and south regions extend all the way to the edge. The east and west regions are sandwiched. So border layout gives you a way. What's the maximum number of items that you have in a JPanel with a border layout? What do you think? What's the max? 5. If you put 2 items into the same spot, it doesn't go down well. Results are random. So you should never put more than 1 item at each location. So that's border layout. And border layout is going to respect remember we had policies for preferred size and maximum size. So the only sizes it respects is the height for the north-south regions and the width, preferred width, for the east-west region. So if you try to resize one of these windows, in fact, yeah, we'll get to it, but yeah, let's do it now. Really what I want to do is erase it. How do I erase? Usually I can erase it. There we go, clear ink. So let's go to border layout. Come on. There we go. Now, watch this piss me off. Okay. What should Firefox do with this file? Let's start it. Apple. No way, Jose. Can't be opened because it's from an unidentified developer. Let's just try to monopolize the iTunes Store as much as possible. For those of you not familiar with OSS Mavericks on Mac, they basically, anything that tries to run that's not from their App Store, they say, denied. It is so annoying. So you have to go to the downloads and go to it and shift right click and say, why yes, it really is okay. Is it okay? Yes, dumb thing. I just said it was okay. Why would I have pushed the launch button? Oh, yet again. Are you sure? Really? Do you really want to run it? Huh? Oh, what an annoying thing. Okay, so here's the border layout.
I just love how Oracle is an unknown developer.
Yes, well, there we go. That's right. Oracle is an unknown developer. So watch what happens when I resize. Notice that it's respecting the height and width for the north-south regions, and it's totally ignoring it for the east-west. But now as I get smaller, it's respecting, as I move it horizontally, the width for regions 3 and 5, and it's giving it all to the center. So you can see that the center region gets whatever is left over. It totally ignores the preferred size for the center region, and it just gives it whatever is left over. So that's border layout. And that's every layout manager has different ways of dealing with the preferred sizes, but as you can see, border layout does a lot of ignoring of your suggested sizes and just says deal with it. So you often have to deal with the fact that it ignores your preferred minimum and maximum size and just says, I don't care what your maximum size is, here it is, deal with it. That's border layout. So typically it's at the top level because most applications, like here's my browser, would use a border layout. Here's the top layout, here's the main browser window, that's the center. Down here is the bottom. Whoops, not there. There. Oh. Right here. That's the bottom. So that'd be south. So border layout, nice for doing high-level layouts. So the next one is box layout, and it's good for stacking things. When you want stacks, then vertical stacks especially, but sometimes horizontal stacks or horizontal lists, box layout is good. And let's see, so it tries to initially put everything to respect people's preferred size, but it's the only one that really respects your minimum and maximum size preferences. So it makes the size of the container equal to the width of the widest element. So here, that is this one. And then the height for a vertical stack is just the sum of the preferred heights. So width is maximum of the preferred widths. Height is the sum of them. So if you go and run it, this one I actually download it prior to class. Okay, so here it is, and whoops. Now if I make it bigger, notice, so I explicitly said I changed button 3's minimum and maximum size. So as I get bigger, notice that its width, see how button 3's width is growing? And notice at a certain point it stops because the width of the container became bigger than button 3's desired maximum size, so then it went to the alignment constraints. Now if I start making it bigger, see how button 3 starts getting bigger until eventually we go past its desired maximum size, which I guess I can't even reach here. Oh well. Can't make it big enough. But at any rate, it also had a maximum size, and if it had gotten to the point that was big, you would have seen some separation there. But you saw the other things stayed at their natural preferred width and height. So box layout, good for laying things out vertically and horizontally. We'll talk a little bit more about it in a moment. Then flow layout is the simplest of the ones. It's the default. So flow layout is the default layout manager for a JPanel, except for the content pane. The content pane's default layout manager is border layout. Every other JPanel, though, when you create it, its default layout manager is a flow layout. And it's the simplest. It just lays them out horizontally, and if there's not enough space, then it will wrap it into a second row. So if I did this one, how to use flow layout, and we'll launch it. Applications. Okay. Is it really going to do it this time? No. There we go. Denied. Flow layout. open with, open. Maybe if I said do not show. Okay, so here's flow layout. And you'll see that if I make it too small, it starts to go to another row. And eventually it just loses when there's not enough space. But it goes to different rows. And here you can change so I'll make it too big. So you see it's right justified. You can make it right to left. And now you see it swapped it. So that shows you how you can change the component orientation. But flow layout is the simplest thing. It's good for just laying things out left to right as a list. So often you do that if I have like a toolbar like here, this toolbar right here, most bookmark bar, good for a flow layout because you're just laying them out one after another, natural size. Then the grid layout lays things out. Everything has the same height and width. So totally what it does is it finds the maximum width of any of its components and the maximum height and lays them out at that in a table with that width and height. And the order in which you add the components is the order in which they're laid out. So in this case, you can see they were added, button 1 was added first, button 2. Then we ran out of, it's a 2-column thing, so then it's button 3, button 4. So the order in which they were added determines the order in which they appear there. And if I resize it, then all the buttons would be resized by the same amount. And you can put gaps there. I'm not going to run this one. What do you think you use this one for? There's a common use for a grid layout. Tool chips, color chips, anything that's a palette where all the things are the same size. So if I had, let's see, terminal window, preferences, there. This would be great for a grid layout because everything is being displayed at the same width and height. Here, this is good for a grid layout. Same width and height for everything. So basically, tool palettes and chips are good for grid layout, whereas this is good for a flow layout because everything should be different size right here. Okay, and then the nastiest one, which we're not going to talk about in this course. If this was my GUI course, we would, but this takes a long time. The grid bag layout is the most sophisticated layout manager because it lays things out roughly in the grid, but as you see, the rows can have different sizes. The columns can have different sizes. You can have objects span multiple columns. They can span multiple rows. If they get more space, like 5 did here, assigned to it than it wanted, you can specify where it gets anchored. Here, this button actually said that it would fill to whatever space was assigned it. So you can control the fill property. You can control the anchor property. There's a whole lot of properties grid bag layout gives us, but it's too complicated for this course. It takes too much time to learn. Okay, so taking it down.
So if you wanted an object that, like you said, that just fills whatever space it has, how would you set, like, would it just have like a, would you just not specify a minimum and a maximum size, or?
No, everything has a default. The default minimum and maximum size is the same as your preferred size. So if you don't provide an explicit one, it just says it's your preferred size. So it all depends on the layout manager. You provide properties to the layout manager actually that tell. So you provide your preferred minimum and maximum size, but the layout manager ultimately is free to ignore it. And the layout manager you can also then give hints to as to whether to fill or to leave it at its normal size. But each of them these are policy choices, and each layout manager will implement different policy choices. Any other questions? Okay, so pretty soon I'll turn you loose. So just a few more details. Each of the layout managers has properties, so we already told you border layout has 5 regions. You can specify gaps between the regions. Flow layout, you can specify gaps. You can also set the alignment for the items to be either left centered or right aligned. If the, well, you can play with it. It's easier to play with it. Grid layout, you can set the gaps, and you can either specify the number of rows and columns, or, as was done in the one right here, what they did was they said that the columns was 2, and they said the rows was 0. When you set one of the two to 0, it means there can be an infinite number. You can't set both to 0 because then it'll have no idea how to lay it out. So typically, you give it, if you want it to be 2 columns, if you want it column oriented, you give it the columns. If you want it row oriented, you give it the rows. And box layout. The interesting thing about the box layout is first you can choose the axis, either y-axis or x-axis, for laying it out vertically or horizontally. And we've already talked about its preferences. The neat thing about box layouts is they have these 2 kinds of filler objects called glue and rigid areas. So what you can do with that is pretty neat. Okay, so rigid areas put constant space between objects. So if I want it to have, say, 20 pixels between button 1 and button 2, I would insert what's called an invisible filler object called a rigid area. Okay, and it's invisible, and I would make its height be 20 pixels so that there'd be 20 pixels of separation. Whereas glue is elastic. It will stretch or compress to absorb any additional space that the layout manager provides. So remember, the box, many times you'd like to stay at your preferred size. So by putting glue in, the glue objects will take all the extra space. So let's say I wanted button 1 to always be pegged to the top of the window. So let's say I have a window. I always want button 1 to be pegged to the top of the window and button 2 to be pegged to the bottom of the window. The way I ensure that is I put vertical glue between them. So the vertical glue will suck up all the additional space. So if I resize the window, the vertical glue will take up all the extra space, and button 1 and button 2 will stay anchored to the top and bottom of the window. If I want it to have 3 buttons and I wanted them to all be equally spaced, equal space between them, then I could put vertical glue here, vertical glue here, vertical glue here, and vertical glue there, and they'd each get an equal amount of the extra space, and the objects would be equally spaced. So box layout gives you these 2 types of invisible filler objects: rigid areas that give you a fixed size, and glue, which gives you elasticity. And when you're looking into boxes, you'll see 2 classes called horizontal struct and vertical strut. Never use them. Okay? It turned out that these were the things that used to be used for fixed horizontal space and fixed vertical space. They both have bugs. and it was only discovered long after the fact that it was released, and it was too late to go back and fix it, but they have bugs in them, so don't use them. Use rigid area instead. If you want a vertical rigid area, you just tell it that the width is 0 and the height is 20. Actually, yes, you say width is 0 and height is 20. That gives you a vertical region. If you want it to be a width of 20, then you give it a width of 20 and a height of 0. And that's how you create your rigid areas. So you give them both a width and height. Okay, so that's the cool thing about boxes. You can shove stuff in those filler objects between the components, and that helps you to control the spacing. Okay, so that's box layout, and they're used so often that they actually created a box class that allows you to, instead of having to create a box layout manager, there's actually a box class whose default layout manager is a box layout, and it provides static methods for creating a horizontal box, a vertical box, and then these three commands create your filler objects. So that's how you create the filler objects. So remember the box class, because if you're going to use a box layout, just go look at the API for a box class. Okay? So I know I'm going through it quickly. I know you won't remember most of it. I just want you to have the high-level details. You're going to have to then look at the APIs. Basically, when you do your homework, you're just going to have to look at the APIs, okay? And you're going to have to look at their sample code. There's no way around it, and I can help you. The last thing is event handling. So when you click on these things, you typically want something to happen. So for example, if I go back to my play thing, and I run it, okay, and I click on button 3, and it pops up a little thing that says button 3 pressed. Well, that doesn't just happen magically. There's something that makes that happen, and it's called an event handler. And the easiest thing to do is just show you the code. So here's the code right here. So what I did was I added something called an action listener. So Java uses what's called a listener model. If you want to be informed of an event, then you tell the event generator, in this case this button, that you want to hear about its events. And you do that by adding yourself as an event listener. So in this case, the button fires an action event and therefore defines this listener interface called an action listener. So we add ourselves to it, and this is, what is this new object? Remember I talked about it earlier in the semester. What does that do? What's it create? Nope.
Oh, that's an anonymous inner
That's an
class.
anonymous inner class. So it's creating an anonymous class, so it's taking the action listener interface and extending it, or actually is creating a new anonymous class, and it is overriding the single method that's defined by an action listener, which is called action performed. And you can see that I am popping up a message using a J option pane saying show message dialog, and this provides a reference where it should appear. So that's a reference frame, and that's the message. So the way that you get stuff to happen is you create these action listeners, override the appropriate methods, and you change various values in your interface. So every event, so Java has a bunch of predefined events. For the homework assignment, the event that you care about is action event. But it has other ones. It has mouse event. It has key event. It has a ton of events. Every event has a listener interface. So action event has an action listener. So for every XXX event, it has an XXX listener. And it also has something called an XXX adapter class. So this is an interface. This is a class. And you can read about them. Basically, listeners may have 5 or 6 methods, and they're empty method bodies. You don't want to often you don't care about all of them. You may only care about like 2 or 3. Like mouse event has mouse down, mouse up, mouse pressed, mouse released, mouse click, mouse entered, and mouse exit. And often you don't care about some of those events. So the adapter provides a class that provides empty method bodies for all the methods, and you can just override them. If you implement the interface, then you have to go and implement all of the methods. So you often end up using the adapter classes. And then you register yourself with event generating entities. So like a button generates an action event. So if you want to be called, you say add action listener. And then you have to provide an action listener object that implements the events. So that's what I did back here, is I actually implemented the action performed event and had it show a message dialog. Okay, so going to turn you loose on the homework assignment. You are going to have to look at the Java APIs. There's a lot of detail there. You're going to have to look at the tutorial and look at the example code. There's just no basic substitute for looking at the code. I know for a fact I've talked about this stuff for like 2 weeks at a time in my GUI class, and everyone gets bored and stops listening to me. So it's useless for me to lecture any longer. You're just going to have to dive into it. Ryan and I will circulate. Feel free to talk to your neighbors. Just get started. You can't do problem 1 of the homework assignment yet. I will be posting a video lecture for next time that will allow you to do problem 1. You need to start on problem 2. Okay? And it's going to be frustrating at first, so just try to get started. We'll be circulating. Feel free to ask questions.
So, just go ahead.
Someone had a question? Yes.
So is this going to be due next Thursday?
Yes.
So, does Java have an event for when a window loses focus?
Yes. Window focus event. Or I think it's a component focus event. Or focus. Pardon?
I can't remember that.
Yeah, I think it's a you have to look it up. There is something for it, like focus event or component event.
So are they similar to like JavaScript events?
Yeah, pretty similar. Java has a richer set than JavaScript, but yep.
Well, there's an interface called the focus listener.
Yep, that's it. That's the event.
Yeah, it's the event focus event. So there you go.
Okay. Yeah, I will. Someone just said, could I kind of go over the question? I'll go over the question quickly because that will help. So let me just quickly go over the question. So first of all, let me run it for you. So Java jar slider app 0, 100, 50, and 10. So basically what you're creating is this little interface here. So it's got a slider. You can move it around. As you move it around, you see that the value is updated. And there's a decrement button. And the decrement, see I had 10 here. That's the amount by which you increment or decrement when you push the increment and decrement buttons. If you get it down, notice here it's 1. I said that the limits were 0 and 100 right here. So if I try to decrement it, it just sets it to 0, so I can't ever make it go negative. Same thing up here. It's 88, increment, 98, increment again, it just sets it to 100. So you have to make sure it doesn't go past your minimum and maximum. 50 is the initial default value here. So basically there's three things, there's two views here. Okay, so there's a what I call a text view in the assignment, and that's what is displaying this value 100. And basically you can use two J labels here, or so one for the value and one for the 100. And every time you click decrement, increment, or the slider, you're going to have to update this particular J label. And every time, okay, so that's the text view. Down here we have the slider view, and it has three objects: a button, a slider, and a button. And every time you hit the decrement and increment buttons, you're going to have to change the value of the slider and the value of the J label. Every time you change the slider value, you're going to have to update the value. So you're going to have action listeners for the two buttons. Okay, slider has a different thing. It has a change listener. Okay, so for a slider, you're going to have, slider is going to use a change listener. So, here, slider has a change, fires a change event. So you're going to have to use a change listener. And basically what you're doing is you have to create a J panel for the text view. So you'll have your basic layout. You're going to have a top level J frame, and it has a content pane. Okay, so this is the content pane. And then you're going to have to create two J panels. One that's going to be your text, hold your text view, and one that's going to hold your slider view. So here you're probably going to add two J labels. One for the value and one for the actual value. So I'll call this the value label. Then over here, you're going to have presumably a J button for your decrement, a slider, a J slider, and another J button for your increment. And you're going to have to choose layout managers. So this one, already remember for the top level, the content pane has a default border layout, so that's okay. But for these two, you're going to have to figure out which kind of layout manager to use, and then set the properties appropriately. Use the set layout command to set the border layout. And then for your three things here, you're going to have to provide event handlers for each of them that does the appropriate thing. Okay? So that's kind of a high-level overview of what you're going to do. And I would definitely suggest starting with a piece of code from the tutorial, like say the box layout manager, and taking a look at that code and figuring out what it does, okay, rather than trying to write it from scratch. So I think the box layout manager is kind of a good, the demo code is a good place to start from. Okay.